A ball is rolling in a straight line and has an acceleration function of a of t equals 12t. T is measured in seconds, and a of t is measured in feet per second. Per second, it is acceleration. The ball is at position 3 feet and has a velocity of 4 feet per second at t equals 1. Lots of useful information. Let's just read the first question and jump in. Write the position and velocity functions. We can't do position first, we'll have to do velocity first. We're working our way backwards from a of t. So, very beginning of these notes said, the derivative of displacement is velocity, the derivative of velocity is acceleration. You knew that. Read it backwards. Acceleration integrated gives me velocity. Velocity integrated gives me the displacement. So let's do it. I'll start with velocity. The velocity is, okay, I can't just be like v of t equals. I need to like articulate what this is. The antiderivative of velocity, I say I can't just say v of t equals, and they assume that I'm talking velocity. I'm defining velocity as the integral. That's what I'm really trying to say. It's that. And that gives me the integral of 12t dt, which is the antiderivative of that. So 6t squared plus c. It is an indefinite integral. We're not dealing with a certain interval yet. So I don't know what c is. I'm going to find it very quickly. But continuing to read, the ball is at position 3 feet. Position, that's not velocity, that's not acceleration. And has a velocity of 4 feet. Oh, my velocity is 4 feet per second at t equals 1. So 6 times 1 squared plus c. So c equals negative 2. So my velocity function is 6t squared minus 2. Okay, good to know. I have answered part of the question. I still have to write the position function. So, doodly-doodly-doodly-doo, changing colors. Let's go green. The position, we'll call it S, is the integral of velocity. And it is 6t squared minus 2 dt. t cubed, 2t cubed minus 2t plus c. Pause right there. Not necessarily wrong, but we just found c. C was negative 2. So we might be like, oh, c equals negative 2. Technically, this is a different c. We'll call it c2. If you want to come over here and call this guy c1, you can. They are two different c values. Just a little thing I do. So we know the position is 3 feet, so the position is 3 at 1 second. So 2 times 1 cubed minus 2 times 1 plus c2, which gives me a c2 value of 3, which means I can now write my position function. So 2t cubed minus 2t plus 3. Yeah. You happy? Me too. Find the total distance that you traveled. How far did I travel? Well, the area under a velocity curve gives me distance, right? The integral of a rate gives me the quantity. So the integral from 0 to 4 of my rate gives me a quantity, but I might have moved forward, I might have moved backwards, so let's double check that. And we'll type that in the calculator, and we get a number. What number do we get? Let's find out. We get 60 squared minus 2. Math 9. Oops. Math 9. 0 to 4. Oops. Jumped the gun there. Math. Absolute value. There we go. And Y1. Do I press buttons too fast? I'm using these calculators since the mid-90s. I'm kind of used to them. 121.540. Total distance traveled. Let's put units on this. 121.540. And that is the distance it traveled. That would be so many feet. Okay. Where is the ball at t equals 4 seconds? I don't know. Let's find out. So I want to know the displacement of the ball. And your first gut reaction might be, okay, all right, I got you. And this honestly, I typed this problem, but when I did, I kind of went through it later and kind of fooled myself with it. Where is the ball? Well, how far did it travel from 0 to 4? Where's the ball? And then I need to find out where it was at the beginning position. Since when was 0 in this problem? Right? Really. Where's the ball at 4 seconds? I don't know how far it traveled from 0 to 4, but I can find out how far it traveled from 1 to 4. Let me rephrase that. I can find its displacement, not how far it traveled. That would be total distance. Okay, yeah, we're dealing with 0 to 4 here, but here's the real issue. I need a starting point. I don't know where the ball was at 0, so I can't start this thing at 0. I have to start it where the ball was. And the ball was at position 3 when 1 second had elapsed. So if you want to get technical, you could be like, oh, S of 1, which is 3. I mean, if you want to write all fancy-pantsy, but I'm not wearing my fancy pants. But S of 1 is 3. That's where this thing begins. But when I say begins, I don't mean begins at 0 seconds. It begins at 1 second. And then plus whatever this is. And I will save you the trouble. I have already done this problem from 1 to 4. The velocity is going to be 120. So 123 feet.